Welcome back, History Department. Look, comment section said I needed to check out Lindsay Nikole. Lindsay Nikole, she has a series on the history of Earth as we know of, right? That we know of, I'm sorry. And she has a playlist with all the videos. So if it's good, I'm gonna run through the videos. I'm even gonna do the introduction she's doing. So for this reaction, I'm gonna react to the intro and the first official video. All right, so let me see what the homie Lindsay talking about. Off jump just from the first scene here. For y'all don't know, I'm Panamanian. I'm American and I'm Panamanian. My parents are Panamanian. My entire family's Panamanian. My grandfather was Jamaican. I was born here in America and raised in America. That looks like a Panamanian mola in the back. And maybe I'm wrong, but that looks like the mola of the native Panamanians. Let me know if I'm wrong. I might be wrong because I don't know if another country used that mola or not. I don't know if they did that style of art. But let's rock. Let's rock. I'm rambling. Let's go.
Okay. Hello. Tomorrow I'll be uploading the first episode of a series that I've been hyping up for a while now. The history of life on Earth. That we know of. A long form version of the TikTok series that I made about a year ago that covers how life evolved over like 500 million years. It will cover 12 geologic time periods, introducing you to extinct species from the Cambrian all the way to modern day. It will most likely take about a year to complete. So I decided I would make this little introduction video to give you a couple disclaimers. Number one, if you're familiar with geologic history, you know the Cambrian is definitely not the beginning of everything. The Earth is estimated to be about 4.5 billion, with a B, billion years old, and life has existed on this planet for the majority of that time. So starting from just 500 million years ago might seem like a jump, to say the least. But the beginning of the Cambrian marks a really significant moment in the evolution of animals called the Cambrian explosion. Most of the major groups of animals appeared for the very first time, at least in the fossil record. And for a while in the scientific community, fossils from before the Cambrian explosion had never been found. Charles Darwin even talked about it and said that the missing pre-Cambrian history of animal life was one of the greatest unsolved mysteries in natural science. We had an abundance of records of animals from everything after the explosion, but nothing from before. Of course, now we know that was not the case. Our understanding now is that life has been evolving for billions of years. But I kind of want to follow that timeline of discovery, starting with this explosion that for a while was the beginning of animal life, and then highlight each of the periods that followed, and then once the series is done, go back to the pre-Cambrian and cover the more cryptic evolution of life. Also, between you and me, most of the pre-Cambrian evolution of life is like cell stuff, cells evolving in complexity, which we all know I don't fuck with cell biology. So it's not something I feel comfortable covering now anyway, especially to start the series off. But we will get there nonetheless. The series is pretty important to me because it kind of sums up the reasons why I got so into evolution and paleontology in college. I used to have pretty bad existential anxiety when I was like 19 and 20. My place in like time scared the shit out of me. So once I started learning about evolution in college, which I never really paid attention to before, I was like, oh, okay, this is how the world works on a really large scale, you know? Okay. And then I wanted to know what came before us, and then before that, and so on. And I got really excited about it. And I guess I kind of channeled that anxiety I had into learning about the deep past. It really helped for some reason. So while I think learning about and talking about extinct species and weird species is fun, I get excited about them because they're just really tiny fragments.
I find it so interesting that people do that. Like, she went through elementary, middle school, high school, got to college as a pre-adult / adult. You know, that 20 and 21 is like, you really kind of still a teen, but you are an adult legally. And she decided to dive into this. It's fire.
Of this massive, incomprehensible mechanism that is so much bigger than all of us, but also connects all of us to everything that is currently living and everything that has ever existed. And that is just so fucking insane. So in this series, I'm going to introduce you to how nature unfolded over millions and millions of years, or at least the parts we know. Because this is a zoology channel, it's going to be extremely biased towards mammals, but I'm going to throw in a little bit about plants and fungus from time to time. And of course, as always, new shit is being discovered constantly, tweaking our understanding of the deep past, so I'll do my best to stay as up to date as possible. So, I hope you're as excited as I am to see this series unfold. Thank you for taking the time to reach the end of this video, and I'll see you tomorrow.
All right. All right. Hold on. Let me make sure there's nothing at the end. Okay, cool. There's nothing at the end. Let's jump over. I just think this is crazy. I feel like I'm about to like this. Let's see. Let's jump into the first video after this, which is the
Cambrian period. This video is sponsored by Rocket Money. If you were to travel back in time to 500 million years ago, the world would look completely alien to what you know now. Grass and trees didn't exist yet, even animals on land. And the ones in the water took shapes that seem so vastly different from the ones alive today. This bizarro world is known to us as the Cambrian period, which lasted from 542 to 488 million years ago. The start of the Cambrian was marked with an explosion of animal diversity that still perplexes scientists today. During this explosion, most of the major groups of animals appeared for the very first time, at least in the fossil record. This period was Mother Nature's trial run for size, shape, ecosystem structure, and behavior. The world had plenty of empty roles to fill and even invent, so things got weird. I'm going to introduce you to some of these stranger species, explain why the Cambrian explosion happened, and even show you ancestors of some animals alive today. My name.
Okay. So is she saying that they believe this period started based on the fossil records? Like, that's their starting point. That's what I think I'm getting from this. Like, that's the starting point. The fossil records is telling us what happened because we can't really find anything else prior to.
My name is Lindsay Nikole, and this is the history of life on Earth that we know of.
That we know.
We're going to start off by getting the general global conditions out of the way. Of course, this was a period of 54 million years, so there were plenty of fluctuations, to say the least. But really just some broad average general stuff so we all have context of what the fuck was going on during this time. Starting off with what the world looked like. Most of the northern hemisphere was submerged underwater, with the majority of land masses located somewhere under the equator. Aside from some... I feel like a weather reporter. Aside from some of the scattered land masses that you see, there was also a supercontinent, Gondwana, which consisted of parts of modern-day Africa, Australia, Antarctica, India, and South America. Okay, wait, let me slow down because you might be thinking, what about Pangea? Pangea was the prehistoric supercontinent we learned about in school. What's going on?
We did learn about Pangea. You're right. You're right. She's right. She's right.
Might be thinking, what about Pangea? Pangea was the prehistoric supercontinent we learned about in school. What's going on? This was way before Pangea, like hundreds of millions of years before Pangea. We'll get to that in like a couple months. So Gondwana saw some pretty significant shit before Pangea even thought about existing. Aside from that, the climate was generally warmer, and there was a decent amount of oxygen in the atmosphere compared to before, and the oceans were rich in nutrients, with some newer evidence suggesting there were likely bursts and dips of oxygen cycling happening in the seas in the earlier parts of the Cambrian, which likely played a role in the Cambrian explosion. So what exactly happened during this explosion? As I had mentioned in the introduction video for this series, there were animals alive before the Cambrian that had pretty cryptic identities in the fossil record. They were smaller, soft-bodied, and kind of restricted in their diversity. And then suddenly from a geologic time point of view, like a couple million years, animals were showing up in the fossil record that were bigger, explored new habitats, had hard parts like exoskeletons and shells, and came in a huge variety of new shapes or builds, i.e. morphologies. This explosion happened over a period of like 40 million years, with the meat of it happening in 13 million years at the beginning of the Cambrian. And the reason why it happened isn't clear cut, more like layers and layers of shit that all snowballed into a explosion and resulted in this. I mentioned bursts and dips of oxygen in the ocean, and that was likely a very small fraction of it, like an almond mom sized slice of pie. You know, animals were also starting to evolve more complex structures like organs and organ systems, repeating body parts, i.e. segmentation, opening up the opportunity for new roles in their ecosystems, which put pressure on other species to keep up. Structures became more complex, so relationships between species became more complex for the very first time. For example, some animals started exploring life in the ocean ground, which was a big deal. This happened before the Cambrian explosion, but based on trace fossils, the time they spent in the ground became more significant, with evidence of more complex burrows that branched and went super deep and whatnot. That led to species evolving predatory relationships with those animals that were in the ground, and so on. One of the bigger developments during this explosion was the development of hard parts, like shells and skeletons, a process called biomineralization, an animal or organism producing minerals. This led to new body plans held in place by skeletons, providing structure or animals producing shells for protection. That's a big deal. Like brachiopods, dude, blew up everywhere during the Cambrian. They were all over the place. They had this new sweet armor. This might have been a response to changing calcium concentrations in the ocean, because shells and skeletons used and still use calcium as like the base. They use it as the base. But there was also likely increased predation pressure with the new ecosystem rules and whatnot. So biomineralization was also a defensive response in a lot of cases. This was all happening for the first time, which is crazy to think about. You know, this is some serious primitive stuff, you guys. This is serious primitive stuff. So what were some of these major groups that seem to have appeared during the Cambrian explosion? Arthropods, mollusks, annelids. I wrote mollusks twice, echinoderms and chordates, which is the group that we belong to with other vertebrates, and also sea squirts. Real quick sidebar, because I'm sure you're wondering what the fuck we have in common with a sea squirt.
Right.
So chordates have this really unique set of characteristics that they have for their whole life or just part of their life, like maybe in the embryonic stage or a baby stage. That is a notochord, dorsal hollow nerve cord, pharyngeal gill slits, and a postanal tail.
I'm learning a little more than just the timeline and the history here. I'm learning terms, cause what the fuck? What? I'm gonna have to really lock in to keep up with all these terms, because she's bringing them back up, as in to say you should have paid attention the first time when I said it about what it was, because now I'm saying it again and not explaining what it is. I like it.
Is a notochord, dorsal hollow nerve cord, pharyngeal gill slits, and a postanal tail. If you've ever taken a zoology class, I know that shit is burned in your brain. A sea squirt, as a little larva, looks like this, and then turns into this. So they've got all that at the beginning. For the sake of this video, the only thing you need to remember from that list is a notochord, because it's gonna come up a couple times. Chordates have notochords, a cartilaginous skeletal rock. Boom, that's it. So let me introduce you to a couple of these early chordates, starting with Hycuichthys. Looks exactly like you'd expect it to look. Simple body plan, nothing crazy. It was discovered in the 90s at the Xinjiang fossil site in China, which has unearthed some of the most well-preserved fossils from the Cambrian, with even soft tissues preserved from time to time. Pretty sick.
Wow.
Hycuichthys, let's shorten it to haiku so I don't have to keep saying that, was alive about 518 million years ago. There have been over 500 fossil specimens found of them, which led scientists to determine that they were about an inch long. Inch. Little guys. Had a distinct head and simple gills, a notochord, boom, and a sail-like dorsal fin running down all the way to the end of their body. They also had eyes and possible nasal sacs in between them, which was a big deal this early on in vertebrate evolution. And they were likely active, but not excellent swimmers. Also good to note that jaws hadn't evolved yet. I know that is impossible to comprehend, but their mouth was just a little circle. None of this yet. And there were plenty of other fish like haiku that had pretty much the same set of traits, just slightly different, like Miloconmingia. Even this early in the existence of chordates, there was diversity in their kind. Let me give you a haiku about haiku. A small, delicate fossil of a vertebrate fish from the deep past. Thank you. Okay, let me show you another chordate that was a little bit weirder. Pikaia, named after the pika, the relative to rabbits that lives near the fossil site they were found. The Burgess Shale in Canada, one of the most well-known fossil sites in the world because of how many Cambrian species have been discovered there. It was described in 1911 by paleontologist Charles Doolittle Walcott. Sick name. He's gonna come up a lot. He practically described everything in this video. Like, his name was just everywhere. Matter of fact, let's make it a drinking game. Go grab a glass of water or a margarita. Pikaia was alive even earlier than haiku, about 530 million years ago, so pretty close to the start of the Cambrian. Today, they are thought to be the most primitive vertebrate that we know of, ancestral to us, frogs, fish, rabbits, rats, birds, sharks, so many things. But that was not always the identity they had in the scientific community. They were actually originally thought to be a polychaete worm, like the bristle worms that we talked about in the worm video. They seemed to have a segmentation like that of a worm. And then years later, in 1979, those segments were actually thought to be muscle blocks attached to an apparent notochord. But the technology to confirm this hadn't existed yet, so the question became fish or worm. Scientists on the worm side of the debate thought that the fish classification was unqualified and forceful. Mumbo jumbo. Hollywood propaganda.
Damn, it's a lot of information. Damn, it's a lot of information.
Classification was unqualified and forceful. Mumbo jumbo. Hollywood propaganda. But a 2012 analysis of Pikaia using electron microscopy said Eat it, bitch. They found the smoking gun. Scientists found myomeres all over Pikaya's body, which are bundles of fibers that only chordates have. Boom. Chordate. Also, I want to add that the myomeres were found by a team led by scientist Simon Conway Morris, whose name is going to come up a lot in this video too. So, add it to the drinking game. Pikaya was obviously a very unorthodox primitive fish. They had a pair of tentacle-like antennae on the top of their head, which made them look like a little bug. I think it's cute. They also had a circular mouth to eat small particles. Remember, no jaws yet. There's also been evidence of mud found in the stomachs of some of the fossils, so maybe they were deposit feeders, eating stuff out of the sediment and accidentally eating the sediment. Before we jump into the next group, let me tell you about today's sponsor, Rocket Money. If you've been following me on this channel, you know a big goal of mine is to do more in-the-field content, travel to different places to make videos. It obviously requires more organization with money and saving, which is where Rocket Money comes into the picture. This amazing personal finance platform has transformed the way I approach saving money. It's been a game changer. With Rocket Money, I can set up budgets without breaking a sweat. I get to label my spending categories, and Rocket Money does the heavy lifting, keeping an eye on my expenses within those categories. Plus, they send me friendly reminders when I've gone overboard. Rocket Money also shows me my spending versus earning ratio, and it does for months, quarters, or the whole year. This has totally reshaped how I see my financial habits and has made me better about my spending. But I think the best part about Rocket Money is the smart savings account feature. I get to decide how much money I want to put away and how often I get to stash it. Rocket Money slides my savings into a smart savings account right there in the app. I can dip into those savings whenever I want. No fuss, no muss. So if you want a smarter and easier way to save money for cool excursions like I do, check out the Rocket Money app. You can also unlock extra cool features with Rocket Money Premium. Go to rocketmoney.com/Lindsay Nikole or click the link in the video description. Thank you, Rocket Money, for sponsoring this video. Now, on to the strange specimens. Another major group to take note of were the trilobites, often considered the dominant group of their time, which I know makes it sound like they were giant beasts terrorizing the seas, but they were actually just little guys all over the place, literally everywhere for a very long time. Not dominance in size, but dominance in abundance, like ants or beetles. So what were the trilobites? The trilobites were a group of arthropods that at first glance don't look like anything special. Like, yeah, that's an arthropod. What distinguishes them from other similar looking arthropods like modern isopods is the shape of their dorsal exoskeleton, their back. It's separated into tree sections. Trilobite, a thick middle and two flat sides. This simple yet defining body form worked really well for them. They were fully developed in the Cambrian, which means they likely came before the explosion, all the way until the end of the Permian period, about 250 million years ago. So 300 million years of this. So get used to them, because they're not going anywhere for the next few episodes. And they stayed
I gotta say this, y'all. Her delivery and how well-spoken she is and how she enunciates her words, it reminds me of George Carlin and how she's kind of funny. Like how George Carlin, this is some comedy shit, y'all. Like George is like a professor when he's on stage, and he's very articulate and he's sharp, and he's jam-packed with information that he's feeding you. I feel like this is what she got going on. Y'all let me know if I'm tripping.
Looking like this. No major developments, which is surprising that such an early body form survived for that long without any major evolutionary changes. Like, that is S tier. They also fossilize really well. I'm gonna put up a number on the board. 25,000. I want you to guess what this number means. Just take a second to guess. How many trilobite fossils have been found? Good guess, but no. That's how many trilobite species have been described. 25,000 separate species scientists have been able to describe and distinguish from the other 24,999 of animals that lived hundreds of millions of years ago. Dude, that is crazy, because that is somehow only scratching the surface of their actual existence due to the fragile nature of the fossil record. You could buy a trilobite fossil on the internet right now if you wanted to. Look it up. That's how many fossils there are of them. Scientists don't even need them. They're like common rocks at this point. They ranged in size from less than an inch long to about 28 inches long. They inhabited every marine ecosystem at the time, from before and long after the Cambrian, interacting with a variety of animals that would be unrecognizable to our eyes today. So let's get into the stranger side of the Cambrian. Starting off with a heavy hitter, Anomalocaris, whose name translates to abnormal shrimp, which, yeah, hit the nail right on the head. If someone showed this to me and said, this is a shrimp, I would say that is an abnormal shrimp. Anomalocaris is considered one of the Earth's first apex predators that we know of. They could get to about 1.5 feet long, which doesn't sound very big, but compared to other animals alive at the time, this was massive. Remember, this was like the grand opening of animal history and evolution and diversity, so they were all still little guys. Due to the nature of their soft bodies, most of the fossils found of Anomalocaris are just their frontal...
Wait, hold on. So you're telling me that at a point on Earth, the biggest, scariest creature was a foot long? That's it? Yeah?
Animal history and evolution and diversity, so they were all still little guys. Due to the nature of their soft bodies, most of the fossils found of Anomalocaris are just their frontal appendages and parts of their mouth, because those pieces are hardened. And that was definitely true for some of the earlier fossils found. The first fossil was just of the frontal appendages. Scientists thought they belonged to some sort of shrimp, hence the name abnormal shrimp. And then a fossil was found of the mouth, but that was thought to be the remains of an ancient jellyfish. Then a fossil with a body and a mouth was found, and it was thought to be a sea sponge, then later reanalyzed to be a jellyfish on top of a sea sponge. And finally, in the 80s, a fossil with the two frontal appendages and the head and the mouth were found all together. It made scientists realize they had their shit all mixed up. And since then, more fossils have been found with this arrangement. Not a sponge, not a shrimp, not a jellyfish. Instead, an early arthropod, specifically part of an extinct group called the radiodonts, which took some unusual forms. Anomalocaris' frontal appendages were used likely in a variety of ways, depending on the species. Grabbing prey, maneuvering it to the mouth, sediment sifting, filter feeding on plankton, etc. And they likely moved through the water all swamped, with overlapping lobes that, combined with their tail fan for stability, made super smooth undulations. They were originally thought to have eaten trilobites, but a new study from this year that used lots of science shit determined that their mouths wouldn't have been strong enough for that, because the trilobites had really hard exoskeletons, but that they were likely fast swimmers, so they suggested higher up in the water column instead of the sea floor where trilobites roamed. Another animal that is often mentioned in any conversation about the Cambrian is Opabinia. Absolutely deviant little fella. I don't even know where to begin. Everything about their face made them unusual and outcasts in the family tree for over 100 years, and scientists had to try and figure them out. They had 5 mushroom-shaped eyes, a trait previously not seen on any other animal. They also had a clawed proboscis that looked like an elephant trunk and was likely used as such, or similarly, digging out worms from burrows, grabbing onto and passing it to the mouth that was on the underside of their body and also facing backwards. So they were determined to be early arthropods, which is probably not a surprise. But the question was, who are their brethren? Nobody else looked like this until just last year in 2022, when a new Opabiniid fossil was found in Utah named Utaurora. They had the same 5-eye configuration and a little elephant trunk, but they just had more of a hairy appearance on their dorsal surface. Finally, Opabinia is not alone in the abyss that is the study of taxonomy. Also, Opabinia was found by Charles Doolittle Walcott. So drink. Actually, here's another one. So that counts for 2. Hallucigenia, which I did in its own video earlier in the year because it is one of the most bizarre animals ever found. Scientists didn't even know which way was up, but I'll still give you a little summary. Hallucigenia, as you can see, looks like some elongated urchin worm. So when they were first discovered in the Burgess Shale by Charles Doolittle Walcott, scientists didn't know what they were looking at. Some sort of fossilized creature that had what looked like 7 pairs of spikes coming out of one end and 7 pairs of squigglies coming out of the other. They initially thought they were looking at an early annelid worm, specifically related to bristleworms. Once again, what was what? Though nobody knew. So then in 1977, Simon Conway Morris decided to take a closer look. He guessed that the spiky half was the bottom, that Hallucigenia walked on stilts, and that the squiggly half was the top, and they were tentacles with mouths at the ends of each of them. I want whatever he was having, because what the fuck? But you know what? Somehow that stuck for 14 years, until new fossils from Xinjiang concluded they had it flipped. The mouth tentacles were actually legs with claws on the ends of each of them, and the stilts were spikes coming out of its back. And then years later in 2015, using electron microscopy, they determined which end was the head side and found little eye spots and a mouth with a ring of needle-like teeth inside of it. They also had 3 extra pairs of appendages close to their head.
Damn, they was trying to figure this thing out all the way up to 2015? I'm thinking this shit happening in the 50s or something.
Using electron microscopy, they determined which end was the head side and found little eye spots and a mouth with a ring of needle-like teeth inside of it. They also had 3 extra pairs of appendages close to their head, which were likely used as tentacles. So maybe they had tentacles after all. Hallucigenia is one of the many species featured in my Spooky Specimens coloring book that you can get on Amazon with Prime delivery. Also, they were 5 centimeters long, max. All right, next. This one to me is giving like amphibious shrimp from a distant planet. Very bizarre. They were found at, you guessed it, the Burgess Shale, and first described by, you guessed it, Charles Doolittle Walcott. He initially called them lace crabs, but then a couple years later described them as some sort of trilobite. Throughout the years, scientists had other ideas based on their set of characteristics. Maybe they were more closely related to the extended arachnid group that included horseshoe crabs and sea spiders. Or maybe they were some sort of crustacean, but nothing ever stuck, because this particular mix of traits was too bizarre. So for now, they sit in their own little grouping in the arthropod family tree. As you can see, they have this unusual head with two sets of spines that extend backwards towards the back, down the length of a body, as well as two paddle-like appendages for swimming, antenna to sense the environment, and they had up to 26 body segments, each with a pair of little legs that branched downwards on each side, as well as gill structures that branched upwards. Fossil evidence suggests they might have been iridescent, like changing color depending on what angle you're looking at it. Like bubbles or a jewel beetle, which is pretty cool to think about. And despite their otherworldly appearance, they have actually been found in tons at the Burgess Shale. Over 12,000 fossils of them have been found. Another slightly less common animal from the Burgess Shale looks like home sweet pineapple, Wowaxia, first described in 1899, with later more complete specimens found by the one and only Charles Doolittle Walcott. Wowaxia was first identified as some sort of worm. But of course this didn't stick, because 1985 came around, and who decided to fuck shit up? Simon Conway Morris. He classified Wowaxia as some sort of mollusk of the shellless variety. He noticed some similarities to the mollusk mouth. And after a bit of...
So one scientist makes a claim and the world runs with it, and another scientist can just come later and say that scientist was wrong? Because hold on real quick. Let me just listen to what she says about what he says about
sort of mollusk of the shellless variety. He noticed some similarities to the mollusk mouth. And after a bit of back and forth between the two groups, annelid or mollusk, there seems to be a consensus that this was in fact an Earth.
So it's all just like he's saying that there's similarities, so it gotta be this. So that dude had to be wrong. Is that really how that works? Like, is that really how that works? I'm guessing that's how that works.
Early mollusk, or maybe relative to mollusks, or maybe the ancestor to Guy Fieri. Wowaxia was covered in these overlapping plates called sclerites. They were also extremely small, just a centimeter tall, including the spikes. Just a little guy, yet also very badass. A couple of honorable mentions of other strange specimens from the Cambrian are Habelia, just looks like a little rug rat, classified as, you guessed it, an early arthropod, and also hyolithids. They look like that Italian guy with no eyes and the mustache that is just key character design, While some of these lineages went on and flourished in later periods, evolving into groups that we're more familiar with today, for others, it was the end of the road, because the end of this period is marked with an extinction that I kind of don't want to talk about, because extinctions are bummers. But luckily, I know just the right person to hand this off to. You know her and love her from the incredible channel Animal Logic, my friend Danielle. Take it away.
Hey, Lindsay. The Cambrian period has a special place in every Canadian paleontologist's heart because we have one of the richest Cambrian fossil localities in the world. There were so many amazing creatures in this period, but unfortunately, all good things must come to an end, and many of those animals didn't make it out of the Cambrian. The Cambrian extinction event is still a bit of a mystery. It happened 485 million years ago and marked the end of several trilobite species. But we still don't know quite why it happened. One of the leading theories is that high levels of volcanic activity caused dramatic climate change. There is evidence of massive amounts of lava coming up to the surface of the Earth at that time, and the eruptions likely changed the makeup of the atmosphere. There are different types of carbon in the air. C12, which plants can absorb easily, makes up most of the carbon in the atmosphere. Volcanic eruptions release a lot of a carbon isotope called C13, which plants don't really love. When there's too much C13, plants will rapidly die off, setting off a chain reaction that can lead to extinction events. On a broader scale, the Cambrian Ordovician extinction event can be seen as the culmination of a series of extinction events, caused by a lack of oxygen in the ocean and an accumulation of toxic hydrogen sulfide. Volcanic eruptions and changes in the water and carbon cycles periodically made the ocean a giant dead zone throughout the
The way I'm hearing it is like she's telling us that the world was like, let's try this shit, man. Oh, that shit ain't work. damn, we fucked up. We shouldn't have did that. Yeah, it's killing everything. Damn. All right, regroup. Let's try something else. Like, it sounds like the world is just trial and erroring some shit right now. Am I tripping? But that's how I'm hearing it.
Cambrian. This was a chaotic time for the ocean, which didn't become permanently oxygenated until about 100 million years later. After the Cambrian extinction, many of the groups of animals we have today arose. But I'll let you talk about those amazing new species. Back to you, Lindsay.
And you bitches are gonna have to wait and see what those animal groups were next video. Okay, fine, I'll give you a little preview. Coral reefs, many snails and cephalopods, and also this guy. Obviously they're not still around, but I wish they were because they're cool as fuck. But I'll tell you about them more in the next episode. So be sure to subscribe so you don't miss it. Check out my Patreon for previews of the merch coming up, along with live streams in our Discord server. Huge thanks to Animalogic for jumping in for this video. Thanks to Rocket Money for sponsoring this video. And for now, stay curious. The world has a lot for us to learn. See ya!
Okay. Shit ton of information. Ridiculous amount of names to remember. Not human names. I'm talking about the ites and the pods. That's what I'm talking about. The ites and the pods. Yeah. I'm gonna watch her videos. I'm gonna watch her videos, y'all. Thank you for the suggestion. Lindsay Nikole. I'm rocking with it. Please like, comment, share, and subscribe. Y'all about to have me brilliant as fuck at my little dinners and holidays, and I'm about to be Mr. Know-It-All. Thanks, y'all. It's fire. This is fire. I'm out, man.